Thank you for having me. I thought this was an appropriate talk to give, given that this our big keynote and everything we were talking about was on generative AI, and is something that I too have been thinking about. So, at our school, the University of California, Irvine, we actually are piloting a brand new seminar series called the Physician Innovator Program. And this is a seminar series that introduces first and second year medical students to different engineering principles and different engineering concepts that they can then utilize in hopes of doing medical innovation and things that they're actually seeing as they're going through their rotations and learning to how to become doctors. It's in hopes of breaking down some of those barriers and fear associated with innovation and being able to actually develop their own products and startups based on their unmet clinical needs that they see. And so, as part of this, we are hosting these 2-hour seminars throughout the year. And one of the seminars that I taught was how to use basic coding principles and how to apply them to things in medicine. So this was a 2-hour seminar. I had 31 students participate. And they were all first and second year medical students with vastly different backgrounds. Majority of them, all but two, were not engineers at all. And so what we did is I had them utilize Octave Online, and I put a QR code in the corner here if you want to try it out. This is a free open source version of MATLAB so that they can always be able to code wherever they'd like. And I picked MATLAB because we oftentimes use this in biomedical engineering, as it has a lot of toolboxes and it's very interactive in that you can get a response right away on your code. We went through basic learning outcomes, so basic skills associated with coding. For instance, what is the difference between a function and a script? What is a variable? How do you assign things to variables? And what types of things can you assign to variables? So different variable types, as well as things specific to biomedical engineering, such as the Fourier transform and how to do frequency decomposition. As many of us biomedical engineers know, a lot of stuff that we do is in the frequency domain because the human body runs on clocks. We run on frequency rather than just things in time. And then I related these things to medical applications and larger skills, such as wireless health systems for the classification of physiological patterns, specifically for how to address things like pediatric asthma and how to measure asthma within the field in children, as well as how to use it for things like EEG and neuroscience. So how can we actually now measure and analyze physiological patterns associated with our brain? What we did is we utilized ChatGPT to show them how to get over the barrier of, oh no, I was a public health student, I didn't know how to code, to show them, again, basic programming skills and be able to, again, critically analyze. So we were trying to really highlight this, think like an engineer, critically analyze, what's good, what's bad about it, what makes sense, what can I now use to modify to create the application that I want. So I made this a very interactive session, the first 20 minutes being introducing of those basic learning outcomes, and then the last 40 or hour and a half or so, actually applying it to a skill. So a practical example of how to analyze just a basic sine wave that could mimic an EEG, and then how to classify it basically using a conditional statement. So again, if you're interested, I do use free versions of things because I don't like people paying. And it also helps from when they graduate, if they still want to perform innovation, what they can do further with that. I had a really great turnout. The students really understood what we were trying to accomplish there and were able to accomplish this task. So I can just show you very quickly. This was, for instance, a practical example of understanding different EEG frequency bands and what behaviors those typically are associated with. And then looking at what that means and what the Fourier transform and what sinusoids and how those relate to EEG. showing them that everything in this world can be made up as a sum of sinusoids. Anecdotally, I did have a student even apply it to her own EKG by the end of the class, so they really enjoyed doing it. And with that, I will stop sharing so that we can stay on time.